The quanta physics theory represents a fundamental departure from 20th century relativistic constraints. It rejects the notion of a warped, four-dimensional space-time fabric in favor of a three-dimensional Euclidean space field, a flat, uniform, and invisible medium known as the kinetic grid. At its core, Kawecki's theory proves that the limits of physics, such as the speed of light barrier and the twin paradox, are not laws of the universe, but mechanical artifacts of baryonic friction. Core postulates of the theory. 1. The invisibility of the vacuum. In the quanta model, the space vacuum is not nothingness, nor is it a flexible fabric. It is a 3D static volume. Because it is perfectly uniform, it remains invisible to sensors that only look for distortions. Once a vessel achieves a massless state, the vacuum offers zero resistance, allowing for transit without the drag Einstein misinterpreted as time dilation. The resolution of the twin paradox. Kawecki identifies the time debt as a kinetic tax paid only by those who push mass through the Higgs field. The Einsteinian error, velocity v, causes time to slow down. The quanta correction, resistance, z, causes clocks to slow. By utilizing a reverse vacuum space field, the ship's effective mass is neutralized. The mechanical clock on the wall remains phase-locked to Earth's timeline, ensuring mechanical parity regardless of speed. 3. The Oort cloud gateway, 1.5 light-year boundary. The theory defines the edge of the solar system, approximately 100,000 AU, as a phase transition. Inside this radius, we are in a density dip caused by the Sun. Beyond this boundary, the 3D space field flattens into the global Hubble flow. This is the high ground of the kinetic grid, where interstellar travel becomes a matter of simple coordinate displacement. The massless propulsion engine. The practical application of the theory is the massless propulsion engine. Unlike 20th century dirty propulsion, rockets, this engine doesn't fight gravity, it navigates the grid. By decoupling from the mass field, the engine allows for superluminal velocity without increasing the ship's weight, or aging the crew prematurely.
The massless propulsion engine of the future. Rodney Kawecki is a theoretical physicist, author, and researcher known for his work in advanced propulsion concepts and cosmological theories that challenge standard models of physics. His research primarily focuses on alternatives to general relativity, often centered around the idea of achieving superluminal, faster-than-light travel through the manipulation of space-time and vacuum energy, rather than traditional warp or bending of space. Key theoretical contributions: quanta physics theory, a framework he developed that aims to bridge gaps in current quantum mechanics and relativity, specifically looking at how the expansion of the universe can be leveraged for propulsion. The Hubble brain, a concept relating to the cosmological event horizon and the expansion of space, which he uses to explain how massless propulsion might be possible within a Hubble universe expansion model. The reverse vacuum space field drive, a signature theory proposing a drive that operates on the same equations as the universe's expansion, utilizing a repulsive vacuum to achieve high-speed interstellar travel. Settings: use appropriate media.
Here's the Gordian knot of relativistic physics. The faster I push a ship, the more the vacuum taxes me by turning that energy into relativistic mass. In Einstein's math, E equals gamma mc squared, and gamma skyrockets toward infinity at light speed. So my fuel buys weight, not speed. But what if I'm paying the wrong bill? Think 2 piggy banks for energy. Piggy bank 1, mass-building energy, the Einsteinian kind, feeds the vacuum's dip around my ship, making it heavier as I push. Piggy bank 2, displacement energy, the Kawecki move. Doesn't shove against the vacuum, it unhooks me from its tension. If propulsion couples me to the vacuum, I'm stuck in traffic. Push harder, get heavier, crawl slower towards sea. But if I spend energy to decouple, like lifting the car off the road, drag vanishes. Now that same energy isn't swallowed as mass, it's conserved and redirected into motion, superluminal motion. This flips the conversion. In the standard picture, acceleration feeds mass and the speed limit hardens. In the kinetic grid picture, acceleration arrives in leaps, hyperjumps at light speed intervals. Why leaps? Because detachment is binary. Hooked to the grid, I feel weight. Unhooked, the weight is instantly diverted into thrust, not mass. Exhaust doesn't bog me down. It stops weighing the ship at all. Think of space as a taut net. Traditional rockets tug the net and sink it, paying the mass tax. Displacement energy cuts the knot, temporarily isolates the ship from the net, so added energy becomes pure displacement across the grid. The paradox breaks here. It's not that I outrun light by pushing harder through spacetime, it's that I stop pushing on spacetime. I reroute the energy that used to inflate gamma into a channel that bypasses mass growth entirely. If that channel exists, the ceiling at sea isn't a wall. It's a threshold. And crossing it doesn't feel like speeding up. It feels like letting go.
I try to read, I go to work, I'm laughing with my